This Everglades in Florida is a vast ecosystem. It stretches on for hundreds of miles behind me here. It's the home to all different kinds of plants and animals. And they're very rare, some of those plants and animals that can't be found anyplace else. Well, the animals that live in this ecosystem and the plants, they all need some source of energy. They get their energy originally from the sun. You see, the plants in this ecosystem use energy from the sun to help them complete photosynthesis, or the process by which they make their own food. They produce their own food. Well, then the animals come along and they eat those plants. When they eat those plants, they're getting the energy that the plants got from the sun. You see, the energy gets passed along from the sun to the plants, to the animals. That's how the energy flows through an ecosystem. Now, you may notice behind me here, there's a whole lot of producers, a lot of plants here, but you don't see quite as many animals around. Well, there's a good reason for that. You see, there needs to be more producers so that they can produce enough energy for all the consumers to eat. It's kind of like an energy pyramid. At the bottom of the energy pyramid, there would be all the plants in the ecosystem. The plants have the most energy and able to supply. Then you would have in the next level some animals, sometimes primary consumers. Primary consumers eat only the plants. And then as you go further up the pyramid, you can get to secondary consumers, which will eat the animals that eat the plants. And the energy just keeps on moving its way up through the pyramid. An animal that's at the top of the pyramid usually doesn't have anything else that eats it. Well, we know a lot about ecosystems and how the energy flows through the ecosystem starting at the sun. But people also use different forms of energy in many different ways. Let's head back to the lab and take a look at some of those ways. Well, here we are. Welcome to the lab. Things are a bit dark around here right now, so let's shed a little light on the situation. You know, light is a form of energy. Thomas Edison invented the first long-lasting carbon filament light bulb way back in 1879. Well, nowadays, light bulbs like this one use different materials, but still operate on basically the same principle as they did more than 100 years ago. They transform electrical energy into light energy and heat energy. Well, here's how it works. When a circuit is closed, electricity begins moving through the whole circuit at the same time. The incandescent bulb has a wire running through it, and part of the wire is made of a special material that gets very hot. This happens as atoms get excited when the electricity passes through. The atoms that make up the wire get so excited, in fact, that they even emit waves of light. The excited atoms in this light bulb are generating so much light and heat that the glass part of the bulb gets hot enough to cause a burn. So don't ever touch a lit light bulb. As a matter of fact, most things that emit light also emit heat. Can you think of anything that lights up that doesn't get at least a little warm? It's because when the atoms get excited enough to emit light, they're usually excited enough to emit heat too. Well, besides a light bulb, some other examples are the sun, a candle, and even a burner on a stove. I'll bet even the TV you're watching right now is getting at least a little warm. Well, speaking of getting a little warm, when you think about heat, you might think about what it feels like on a hot summer day. Or maybe what it feels like when you bite into some hot pizza. Well, heat has a way of moving from one place or one object to another. The way that this happens is through a process called conduction. Conduction occurs whenever two objects touch and heat is passed from one object to the other. Like with the electric burner here. When I put this pot of water on and I turn it on, heat from the burner coils is conducted away to the metal pot. Then it's conducted to the water that's in the pot. The water eventually gets hot and starts to boil. Well, another way that heat can move is through a process called convection. Convection occurs when a substance is heated. Well, what happens to the substance is it begins to expand and become less dense. That causes it to get pushed up, almost like a hot air balloon. And while it's getting pushed up, cooler, more dense particles move in to take its place. And then they get heated and move up. And it forms sort of a cycle. We call it a cycle of convection currents. Watch what happens here. This funny-looking glass tube is filled with water. I'm going to heat it with this alcohol burner. When I do, the water in the tube begins to expand and rise, while cooler water is moving in to take its place. It's a little bit hard to see happening, so I'll add a drop of food coloring. Watch the direction that the color moves. That's cooler water right now moving in where it's being heated. And the heat's going to take that warmer water and it's going to go up because it's expanding and it's rising. And you see how it moves in this circular path? That's convection. Convection is the reason the wind blows. Air close to the earth is heated. It expands and rises, and cooler air moves in to take its place. Convection is also the reason for earthquakes and volcanoes. Huge plates of land shift and move around because of convection happening in the magma under the Earth's crust. It sets ocean water on the move too, as currents of moving water travel between the warmer equator and up to the poles. The last way heat moves is through a process called radiation. Radiation happens when heat moves from one place to another in the form of invisible waves of energy. It's like when you put your hand near an oven or a microwave and it feels warm without even touching it. Or if you've ever been near a heat lamp at a deli counter and started to feel warm. I can feel some radiative heat coming from this flame right here. It's because invisible waves of energy travel through the air and they get absorbed by your skin. It makes your skin heat up and feel warm. It happens with other things too.
Radiation is a form of energy that often travels as waves of heat or light. You felt heat radiate if you ever held your hand close to a light source. You can find out how heat travels as radiation and gets absorbed in different ways by different kinds of materials. In order to do this, you'll need a flashlight, a thermometer, a ruler, some tape, a watch or clock, and black and white paper. The first step is to tape the flashlight about 3 inches or 7 centimeters from the end of the ruler. This will help you keep things steady later. Next, place the thermometer on top of a piece of white paper. Handle the thermometer very carefully and don't touch the bulb at the bottom. This could give you false results. Before going any further, record the starting temperature of the thermometer. Shine the flashlight on the bulb of the thermometer. Record the temperature as it changes every minute for 5 minutes. Allow the thermometer some time to get back down to its original temperature. Then repeat the experiment with the black paper. Compare your temperature readings for both tests. If they look different, there's a good reason for that. Darker colors usually absorb more heat and light radiation energy than lighter colors. Try doing the experiment with other colors of paper and different kinds of surfaces. And the next time you're out playing in the sun, think about what colors might help keep you the coolest. After all, you do want to be the coolest player out there, don't you?